Hi, my name is Patrick Donnelly, and I'm from Oregon State University. And today I'm presenting some work I have done with a student on evaluating social media discourse in an attempt to predict the emotion of the song itself, but without using any of the audio of the song. So this falls in the umbrella of music information retrieval, and there's a task of a music emotion prediction, which we're basically trying to guess what the average human effective response to a piece of music would be. Obviously, this is a very subjective thing, so these data sets are tuned with many annotators and kind of a heavy aggregation. The real problem, though, is there's not that many of these data sets out there because, again, it's an expensive lab study and you have to have 20, 25 or more people annotate the same song. And there's just a lot of music out there. But the industry is very interested in this task because imagine a music recommendation system could benefit from really kind of knowing more about the emotional qualities of random or a new piece of music. So our goal is to try to look at other ways, such as free data, social media commentary, and see if we can guess something about the song itself. This is motivated by work that others have done using just the lyrics of a song to predict the emotion. So we're just trying to find some other source that could maybe tell us something about the song in that vein. So some quick background on emotional models. There's multiple models out there, but there's several psychology models that have been used in this task, some discretized views of emotion in different categories. And in this work, we focus on the third category, which is the most recent work in this field. Is kind of moving this way, which is a continuous, two-dimensional continuous values along an axis of valence and arousal. In the world of music emotion prediction, there's been a lot of work trying to use the acoustic features, trying to use the audio itself, but there's a lot of studies that seem to cap out at this like 68% accuracy on these data sets. And there's just only so much they can get out of the raw audio itself. We're motivated by the work in using song lyrics, and so adding song lyrics to the audio and multimodal model adds small boost to the prediction accuracy on some of these data sets. There's been work using only the lyrics, which can get pretty decent accuracy, or 64% considering it's just the lyrics to the song. And there have been a recent approach using transformers, which is what we use in this work, which got some high accuracy, but again, a very simplified for mood discretized problem. Transformers, as you all know, are a very popular natural language processing deep learning model. They use self-attention to get some context between along the embeddings. We look at two different recent BERT-inspired models, the Roberta model and Distilbert, in this work. So as I kind of alluded before, the big problem in this field is there's just a lack of data. There's also no one problem set definition. So some have used discretized labels or a set of finite moods. Others are using continuous values like we use in this work. There's the subjectivity of response. So, two different people think differently about a piece of music, and that's going to differ both within cultures and between cultures. And so therefore you need large volumes of people to respond to get some meaningful data and error bars. And those are often done in expensive lab studies. So that's why there's not very many data sets. And when there are, there's only 1,000 pieces. And a real problem is the copyright concerns, how there's you can't share freely the audio for some of these pieces of music in order to do more machine learning on it. So we identified 4 data sets that use valence and arousal. But the problem is the first one, DEEM, is a very nice lab study, but they use kind of copyright-free music, so therefore it's kind of obscure or historic, and therefore there's not a lot of social media commentary about it. The biggest one is made by the French company Deezer, which is a great data set, except it's synthetic, and they used text to generate the labels. So it'd be disingenuous. We're using different text, but it's just we're avoiding it because it's synthetic. So we've identified 2 others, and notice they're relatively small data sets. That are annotated with valence and arousal values. And again, these are aggregations of multiple annotators per song, and the number of annotators per song differs by song. Here's a distribution of our annotations on that 2D space. So at least on the left, the A and G, it's somewhat well distributed. On the right side of the PMEMO, which is a recent Chinese data set, and includes a lot of really popular top Billboard chart songs, but we can kind of see that it does favor some regions of the space more than others. So what we did is we took the song list that we have some knowledge about, these existing data sets, and we have the song list. And we were like, let's query the social media things and do a data collection. And so we ran as much as the bandwidth allowed us to do from the API. We pulled social media data for 2 months. So we got recent commentary on those songs. Some of the songs didn't turn any results, and we had to exclude them because we didn't have any social media. But we basically, for YouTube and Reddit, we got the 10 best comments as upvoted or thumbed up, and we included nested comments. Twitter's a very different social media site, and so they're shorter text, and so we grabbed 100 top tweets, and we excluded the retweets because it had duplicate information. So we kind of had mixed yields, as you can see, but for 80-90% on Reddit and YouTube, we were able to find songs, and we collected a few 100,000 comments across this relatively small number of songs. So multiple comments per song. Here's just kind of one example of a song with the Spotify. We see it has a kind of middle of the road valence and arousal, and we have YouTube, Reddit, and Twitter comments. And just what I want to point out is a lot of these they're not critiquing the song. They're talking about like their experience or the concert t-shirt they got or some other thing. And we're just kind of, if we can get enough of this data, can we find something about the sentiment that's also in the song? And that's kind of what we're looking for. It's a very difficult problem here. We collected a lot of comments. As you can see, for some songs, there were obscure songs had relatively few comments, but for some comments, we had lots of 100,000 words about one song. And we do see, even though they're different data sets, we do see very similar distributions between them, which was interesting. So again, we compared a Roberta and a Distilbert model. We used some of the default settings, default architecture layers, number of layers, which was 12 and 6 respectively, and 128 word input. So we had to truncate individual comments that were longer than that. We added 2 dense layers and then trained with our data, and we used mean squared error as a loss. And we predicted valence and arousal concurrently for each comment, and then we aggregated at the song level. And so what we found is that Distilbert and Roberta had about equivalent performance on this data set. And the advantage is Distilbert's a much smaller model, and so it's much faster. And so we continue to use Distilbert for the rest of our experiments. And here's a breakdown of kind of these are our correlations based on the individual social media source. And so we see for one of them, YouTube did significantly better. That had a bit of older songs, and we're looking at recent comments. So YouTube seemed to be better for that. The other data set, which had more recent songs, both Reddit and YouTube did pretty well. And interestingly, combining them all together gave us a small boost for that one that didn't happen for the other data set. In most of our experiments, Twitter did not do very well, but part of that is probably attributed to our process that had to differ between the other two. And as a result, we basically just have less Twitter data. So there's much less information there, but we include the result here. Another limitation of our result is we're getting moderately decent correlations, 0.6, 0.7 of Pearson's R correlation, but our actual predictions are not very good. As you can see, they're clustered kind of in the center. The left is ours, the right is the actual. So while we are differentiating a little bit, or we are finding that the trends, the correlation, we aren't predicting the actual prediction extremely well. Arguably, we don't necessarily need to if we're just trying to differentiate between the songs. But this is caused by two different reasons. One was we have a lot of noisy data. Most of our comments don't have anything to do with anything with social media, right? So there's a lot of irrelevancy. And a lot of those have a lack of emotion words. To fix that, we could prune comments without emotion words, or uninformative or short comments or something like that, or those techniques. We also, why they're really clustered is because we're aggregating at the song level, and so we're running, we're predicting each comment, and then we're kind of aggregating at the song level. So you see that heavy aggregation by clustering all those predictions. So we're looking at some even more recent architectures that might allow us to provide some context between related comments to the same song. As I mentioned before, our Twitter protocol was not the same as the other two, and therefore the tweets are just short, and it was relatively uninformative. So we are ongoing, continuing pulling more data, and we've increased the number of Twitter comments significantly to try to get the volume that matches the others if possible. And we're also enabling to search all-time comments to maybe find better relevancy to some of the older songs. We're also looking at two other social media sources that have some interesting characteristics to do with music, including SoundCloud, which could give us the potential to have comments at timestamps along the song, not just for the whole song. So in kind of conclusion here, we attempted to train natural language transformers using only social media commentary to see if it could tell us anything about the quality or the effective quality of the music itself. We found that YouTube had the highest kind of retrieval and relevancy rates, which is kind of maybe not surprising because YouTube actually allows a lot of music to be shared. So it's actually a video, and therefore it's a music sharing platform as well. Across the two data sets, we didn't really see anything we could conclusively say there were one social media set dominated over the other, except for YouTube's retrieval rate. We noted that Distilbert trains much faster than Roberta here, and we have a very exciting moderate correlation that shows us that there is signal in this social media commentary that can tell us something about the music itself. And so this this could be quite useful in allowing a music service to potentially use free data in order to learn something about this large music catalog that they have. Here are my references, and could I take any questions?